The night sky is a tapestry of twinkling lights. Each point of light is a star. Stars are immense balls of burning gas. They are scattered across the vast expanse of the universe. Stars are not randomly scattered. They are grouped together in galaxies. Our own galaxy is the Milky Way. It contains billions of stars. The birth of a star is a remarkable event. It is a cosmic ballet of gravity, gas, and light. This essay will explore the fascinating process of star formation. Stars are not born in isolation. They form within vast clouds of gas and dust. These clouds are called nebulae. Nebulae are the stellar nurseries of the cosmos. Nebulae are composed mostly of hydrogen and helium. These are the two lightest elements in the universe. They are also the most abundant. These clouds are cold and dark. They drift through space for millions of years. But within these clouds, the seeds of stars are sown. Not all nebulae are created equal. Some are small and faint, others are vast and dense. The largest and most massive of these clouds are called giant molecular clouds. Giant molecular clouds can be hundreds of light years across. They can contain enough material to form millions of stars. These clouds are the true birthplaces of stars. Within these clouds, gravity plays a crucial role. Gravity pulls the gas and dust together. This process is slow and gradual, but over time it can have dramatic effects. As a giant molecular cloud drifts through space, something remarkable can happen. It can encounter a shockwave. This shockwave can be triggered by a nearby supernova. The shockwave compresses the cloud. This compression causes the cloud to collapse under its own gravity. As the cloud collapses, it fragments into smaller clumps. These clumps continue to collapse. They become denser and hotter. This is the beginning of a star's life. Section 5, Protostar Formation. A star is born. In the vast expanse of space, the birth of a star is a mesmerizing process that unfolds over millions of years. As a clump of gas collapses, it spins faster. This is the beginning of a star's journey, a journey that starts with the gravitational pull of a molecular cloud. This is due to the conservation of angular momentum. As the gas cloud contracts, it must conserve its angular momentum, causing it to spin more rapidly. The spinning clump flattens into a disk. This disk, known as a protoplanetary disk, is where the magic of star formation happens. At the center of the disk, a protostar forms. This protostar is the seed of a future star, glowing faintly as it gathers mass. A protostar is a hot, dense ball of gas. It is the precursor to a star, a stage where nuclear fusion has not yet ignited. It is not yet a true star. The protostar is still in its infancy, not yet hot enough to sustain nuclear fusion. It is still too cool to fuse hydrogen into helium. Fusion, the process that powers stars, requires extremely high temperatures and pressures. The protostar continues to accrete material from the surrounding disk. This accretion process is crucial as it allows the protostar to grow in mass. It grows in mass and temperature. As it gathers more material, its core temperature rises, bringing it closer to the threshold for nuclear fusion. The surrounding disk also begins to coalesce into planets. These planets form from the same material as the star, creating a new solar system. Section 6. Nuclear fusion, the heart of a star. As a protostar continues to collapse, its core becomes extremely hot and dense. Temperatures reach millions of degrees. At these temperatures, a remarkable process begins. Nuclear fusion. Nuclear fusion is the process of combining light atomic nuclei into heavier ones. In the core of a protostar, hydrogen nuclei fuse to form helium nuclei. This process releases an enormous amount of energy. This energy is what powers the star. It causes the star to shine brightly. Section 7. The main sequence, stellar adulthood. Once nuclear fusion begins in its core, a protostar becomes a true star. This marks the beginning of a star's journey into what we call stellar adulthood. It enters a long and stable period of its life where it shines steadily for millions to billions of years. This period is called the main sequence. It is the most extended phase in a star's life cycle, where it spends the majority of its existence. During the main sequence, a star fuses hydrogen into helium in its core. This nuclear fusion process is the powerhouse of the star, generating immense energy. This process releases a steady stream of energy which radiates outward from the core to the star's surface and then into space. This energy balances the inward pull of gravity, creating a state of equilibrium. The star remains stable, neither collapsing under its own gravity nor exploding outward. The length of time a star spends on the main sequence depends on its mass. More massive stars have more fuel, but burn through it much faster. Massive stars burn brighter and hotter. They have shorter lifespans, often only a few million years, because they consume their hydrogen fuel at a rapid rate. Less massive stars are dimmer and cooler. They live much longer, sometimes for tens to hundreds of billions of years, as they burn their fuel more slowly. Our Sun is a medium-sized star. It is not the largest nor the smallest, but it has a stable and balanced life. It is about halfway through its main sequence lifespan, having already spent around 4.6 billion years in this phase. It will continue to shine for another 5 billion years before moving on to the next stages of its life cycle. Eventually, our Sun will exhaust its hydrogen fuel and leave the main sequence, expanding into a red giant and undergoing dramatic changes. But for now, it remains a stable and life-giving star, illuminating our solar system. The main sequence is a fascinating and crucial phase in the life of a star, where it spends the majority of its existence providing light and energy to the universe. Section 8. Stellar Evolution: The Changing Fortunes of Stars. Once a star exhausts the hydrogen fuel in its core, it leaves the main sequence. It enters the final stages of its life. The way a star evolves depends on its mass. Low-mass stars like our Sun will expand into red giants. They will eventually shed their outer layers. This creates a beautiful planetary nebula. Massive stars will explode as supernovae. These explosions are among the most powerful events in the universe. Section 9. Stellar death, a blaze of glory. The death of a star is not the end, it is a new beginning. The material ejected from a dying star enriches the interstellar medium. This material can eventually form new stars. Supernovae are particularly important for this process. They seed the interstellar medium with heavy elements. These elements are essential for the formation of planets and life. Section 10. Supernovae, cosmic recycling plants. Supernovae are not just destructive events, they're also creative forces. They play a vital role in the evolution of galaxies. The shock waves from supernovae can trigger the formation of new stars. They can also disperse heavy elements throughout the galaxy. These elements enrich the interstellar medium. This makes it possible for new generations of stars and planets to form. In a sense, supernovae are cosmic recycling plants. They scatter the ashes of dead stars. These ashes become the seeds of new life. Section 11. The significance of stars. Our place in the cosmos. In this chapter, we delve into the profound role that stars play in the grand tapestry of the universe. Stars are more than just points of light in the night sky. They are ancient beacons, each one a testament to the vastness and age of the cosmos. They are the building blocks of galaxies, the fundamental units that come together to form the majestic structures we observe in the universe. Stars are the engines of cosmic evolution. Through their life cycles, they drive the processes that shape the universe, from the birth of new stars in nebulae to the explosive deaths of supernovae. Stars provide the light and heat that make life possible. Our own Sun, a relatively average star, is the source of energy that sustains all life on Earth. Through the process of nuclear fusion, stars create the heavy elements that make up our bodies and the world around us. Elements like carbon, oxygen, and iron are forged in the hearts of stars. We are literally made of star stuff. The atoms in our bodies were once part of ancient stars that lived and died long before the Earth was formed. Understanding the birth, life, and death of stars is essential to understanding our place in the universe. Each stage of a star's life cycle offers insights into the processes that govern the cosmos. It is a journey of discovery that takes us from the smallest atoms to the largest structures in the cosmos. By studying stars, we learn about the fundamental forces and elements that make up everything we see. It is a journey that continues to inspire and amaze us. As we explore the stars, we not only uncover the secrets of the universe, but also gain a deeper appreciation for the beauty and complexity of the cosmos. The study of stars is a testament to human curiosity and our unending quest for knowledge.